Today we're going to take a look at variation and problem solving. So variation can come in three different forms that we're going to look at. We're going to look at direct variation, we're going to look at inverse variation, and joint variation. So first, direct variation. Y varies directly as x, or y is directly proportional to x if there is a constant k such that y equals kx, k times x. The number k is called the constant of variation or the constant of proportionality. So direct variation, a good example of that is a circle, where in a circle, the circumference is calculated by 2 times pi times r. So r is the radius, the distance from the center to the edge, where circumference is the distance around the circle. So essentially like the perimeter of a circle, where it's direct variation because this 2 pi, that's a fixed value. That 2 pi is always going to be 2 pi. And then the radius, what happens is when you change the radius, so if I made this radius 3, that's going to give me a circumference of radius times 2, 6 pi. But if I change the radius, so if I make this circle bigger, let's say now the circle is radius of 6, now it's going to be 6 times 2 is 12 pi. So the circumference is going to increase, but that 2 pi is always going to be 2 pi. So that's our constant, where r is going to change that circumference. Another example also is like distance equals rate times time. When you're driving and you just set like, all right, I'm gonna travel at a fixed rate of 60 miles an hour. How far am I gonna get if I travel for 1 hour, 2 hours, 3 hours? As long as I'm driving at that constant speed, I just set my speed control and I'm going at 60 miles an hour. If I travel for 1 hour, I'll go a certain distance, 1 times 60, which is 60. And then if I go for 2 hours, 2 times 60, 120, 3 hours, 3 times 60, and so on. So you have that result where the time is changing and then the distance is what you get, but that constant would be that speed. And obviously we change speeds and everything, but just using it as an example, the direct variation would be if a fixed speed of 60. So number one, if y varies directly as x, find the constant of variation and the direct variation equation for the situation. So we have the value of y equals 7 and x equals 28. So the directly as x, that's telling us that we're going to use direct variation. Direct variation is y equals k times x. So we substitute in 7 for y. K is what we're trying to figure out, times the x value of 28. So 7 equals k times 28. I need to solve for k. I want the constant of variation. Did I just undo that? Yeah, I did. Find the constant of variation right here. Find the constant of variation. And then we want to get the direct variation equation. So now right now, the constant of variation is the k value. So I'm trying to solve for k. I'm going to divide by 28. K equals 7 over 28, which simplifies. 7 goes into 7 once. 7 goes into 28 4 times. So the constant of variation is 1/4. The direct variation equation then would read this: y equals 1/4 times x. So I'm just replacing k with that 1/4, and then I have my direct variation equation. From here, I could ask a lot of questions. I could say, what is the result of y when x is equal to 10 or 40 or 60 or whatever? I could ask a lot of questions based off of this fact that I'm using some sort of observation of when y is equal to 7 and x is equal to 28. I get a k value, which is that constant, and then I can ask a lot of different questions from there. So let's do an application to this. The weight of a synthetic ball varies directly with the cube of its radius. So a couple key things here. Directly means direct variation. A ball with a radius of 2 inches weighs 1.52 pounds. Find the weight of a ball of the same material with 3-inch radius. So they're giving us two different pieces of information. They're telling us that we have direct variation, so let's write that down. So direct variation, the weight of the ball. So weight, I'm going to notate with W. Varies directly with the cube of its radius. So direct variation is k times the cube of its radius, the radius being cubed. So I'm not going to use like y equals kx every single time. I'm just going to replace it with variables that are consistent with like the scenario here, the weight and the radius. So w for weight, r for radius. So here is our direct variation equation, but I need to figure out what k is. So I'm going to use this first observation where we have a radius of 2, and then we have the weight of 1.52. from that first observation. So that's like this right here in this previous problem. That's like that. That's our first observation. From this observation, I could solve for k, and I could come up with a new direct variation equation with a value for k, and then I could answer this question. So we have two kind of parts to this, two questions that we want to answer. So the weight they're giving us is 1.52 pounds equals the constant, which we don't know, times the radius of 2 raised to the third, because it says the cube of its radius. Cube is raising it to the third. So I'm going to get 1.52 equals k times 2 to the third is 2 times 2 times 2, which is 8. Just like how we did in the last problem, we want to solve for k. I'm going to divide by 8. So I get k equals 1.52 divided by 8. 1.52 divided by 8 is 0.19. So our direct variation equation is W equals 0.19 times r to the third. Okay, now let's answer the next question. The next question says find the weight of a ball of the same material with a 3-inch radius. So I have that k value, I have my constant. Now I need to figure out what W is when my R is now equal to 3. So W equals 0.19 times the radius of, what's the radius again? 3 to the third. So W equals 0.19 times 3 to the third, which is going to be 5.13. 3 to the third is 27, so we're doing 27 times 0.19, which is 5.13. And that would be pounds. So you see how we're using that observation, and then we're answering that follow-up question. Just like I was saying here, here's our observation. We come up with our equation, and then we could answer some follow-up questions. We don't have any follow-up questions on that first one, but this one we did. We had the scenario given, and then we wanted to find the weight of a different ball. And they could ask, what if they're asking with a 9-inch radius, or 12-inch radius, or 15-inch radius, 25-inch, whatever. Whatever they're looking at, we would just plug in R, and then we'd get that weight back. Next is inverse variation. So y varies inversely as x, or y as inversely proportional to x. If there is a non-zero constant k such that y equals k over x, number k is called a constant variation. Same thing from before. So what's happening here is as x is increasing, so as x increases, think about what that's going to do to the y value. Let's just think arbitrarily for a second. So y equals, let's say k is over, let's just say k is equal to 1, just for the sake of argument. So let's say k is equal to 1, and x is equal to 2. So y is equal to 1/2. Okay. What if k is equal to 1? Oh, I keep doing that. And x is equal to 3. 1/2, and then 1/3. Just do one more. What if k is equal to 1? X is equal to 4. What's happening with the y value? As x is increasing, so it goes from 2 to 3 to 4, what's happening with y? 1/2, 1/3, 1/4, 1/5, 1/6. Those numbers are getting smaller. 1/3 is less than 1/2. 1/4 is less than 1/3. 1/5 is less than 1/4, and so on. So as x increases, y is decreasing. Where, I think I just spelled that wrong. Decreasing. Sorry, yeah. Pen was kind of, okay. Decreasing. Where here with direct variation, d equals rate times time, or the circumference. As that radius is increasing, the circumference is going to get bigger. Over here with the synthetic ball, as the radius was going to increase, the weight was also going to increase. Where inverse variation, as x increases, y is decreasing. So y varies, let's do number 3. Y varies inversely. Find the constant of variation k. And the inverse variation for the situation. So we have inverse variation, y equals k over x. So we're going to take y, just giving us 2. K over the x value of 3. So we're going to solve for k, just like how we did before, but this time we're going to multiply by 3, because I want to solve for k by multiplying by 3. So k is going to equal 3 times 2 to 6. So I get the inverse equation, y equals 6 over x. And then from here, we can answer follow-up questions like what happens to y when x is equal to 10, 12, 28, whatever the case may be. But that one was just an example of just making sure we get that equation. Now let's do an example of actual application to this. So it says pairs of markings a set distance apart are made on highways so that police can detect drivers exceeding the speed limit. Over a fixed distance, the speed r varies inversely with time t. In one particular pair of markings, r is 40 miles an hour when t is 6 seconds. Find the speed of a car that travels a given distance in 5 seconds. So let's go through this again. Pair of markings set distance apart on highways so police can detect drivers exceeding the speed limit. Don't get overwhelmed with extra information that we don't necessarily need. Over a fixed distance, the speed r varies inversely with time t. So inverse variation is r is going to equal k over t. In one particular pair of markings, r is 40 when t is 6 seconds. So that's our information. That's our jumping off point. So r is 40 and t is 6. So that means k is going to equal, multiplying by 6, 240. So r is equal to 240 over t. Find the speed of a car that travels a given distance in 5 seconds. So the r is the speed, t is the time, so we're given time is 5 seconds. So r is equal to 240 over 5. R is equal to, and then 240 divided by 5 is 48. So r is equal to 48 miles per hour. There we go. And think about that inverse variation. We're talking about a distance. Speed is increasing. I'm sorry. The speed is increasing, so the time is going to go down. So there's that inverse variation there. Last one, joint variation. Joint variation is a little messy at times. Like it get kind of confusing because there's like a lot of components. It's joint. It's kind of combining everything together, both direct and inverse. So you got to be careful on how you read this. So let's jump into the example. It says find the constant of variation and the variation equation. Y varies jointly as x and the cube of z. Y equals 18, x equal to 6, and z equal to 1. So y varies jointly as x and the cube of z. So that means we're going to do k times x times the cube of z, so z to the third. Now, some problems might say something like varies directly and inversely, like there's going to be like different components, but this one was just saying like direct variation, so k times x times the cube of z, z to the third, and then we just plug in all of the information that we have here to get k. So we're given y is equal to 18, k is the unknown, x is equal to 6, z is equal to 1, so 1 to the third. So 18 equals k times 6 times 1, because 1 to the third is 1. 6 times 1 is 6. Solve for k, so divide by 6. K equals 3. Get our k value 3. And then we would have to write down the equation then. So that's y is equal to 3x times z to the third. And then we'd be able to answer follow-up questions from there. No follow-up question given though. Let's do an example though of a follow-up question. So we have the maximum weight that a rectangular beam can support varies jointly as its width and the square of its height and inversely as its length. Excuse me. If a beam 1/4 foot wide, 1/3 foot high, and 13 feet long can support 12 tons, find how much a similar beam can support if the beam is, then we have some extra information. So let's first just take the first component. Let's write down the equation. It says the maximum weight that a rectangular beam can support varies jointly as its width and its square of its height and inversely as its length. So be careful here because we have the information maximum weight and width. So I'm going to call weight, I'm just going to use the variable r. I don't know, it really doesn't matter because I want to use the w for width. Height, we'll just use h, and then length we'll use l. So it says the maximum height, I'm going to use r, you can use whatever you want, but I'm just going to use r, varies jointly as its width, so k times its width, square of its height, and inversely as its length. So inversely as its length, what does that mean? that means we are dividing by, and I'll use capital L. That means we're dividing by L. We're dividing by its length, because inversely, remember, inversely is division of that value. So we have direct K times W times its width times its height squared, inversely, so divide by L. So now we plug in the information. It says a beam is 1/4 foot wide, 1/3 foot high, 13 feet long, and can support 12 tons. 12 tons is that weight. So R is equal to 12. So I'm going to say R is equal to 12 times K, which is that constant we're trying to figure out. The W is the width, that's 1/4. And I think what's going to be a little bit kind of messy with this problem is these fractions. And then foot high, so the high is the height, so this is the height, this is the width. So this is going to be 1/3, and remember our height is being squared, height squared, so 1/3 squared. And then we are inversely with the length, so it's 13 feet long, so this is the length. We'll go over here. So 12 equals, let's be careful here. I'm going to try to knock out a couple steps here. 1/3 squared is 1/9. So this is going to be 1/9. 1/3 squared, 1/3 times 1/3, 3 times 3 is 9. So 1/9. 1/9 times 1/4 is 1/36. So we have K times 1/36. Because again, this is 1/3 squared is 1/9. And then we have 1/4 times 1/9, which is 1/36. And that's all being divided by 13. I don't know how you want to go about doing this, but I'm just going to take the route of understanding that I have 1/36 divided by 13/1. So that is going to be K times 1/36 times 1/13. And if you're good with your calculator, you could do it that way too. But 12 is equal to K times, and then we have 36 times 13. So it's going to be K times 1/468. And you can just use your calculator if you're pretty good with it. So then I have to solve for K. I have to multiply by 468 or divide by 1/468. I think it's easier just to multiply. So let's go back this way. K is going to equal 468 times 12, which is 5616. So K is equal to 5616. So after all that fancy footwork, we get R is equal to the K value, 5616, times its width, times its height squared, divided by its length. And I know I'm getting close to my camera here, so I want to go above this. I don't want to go to a new page. So I'm just going to work above. Let me write up my... Let's go right here. R equals 5616 W times H squared over L. So now let's answer the second question part. It says the beam is 1/3 foot wide, so that's width. 1 foot high, that's height. And 15 feet long, that's length. And we're going to use that new K value that we just calculated and get the weight. So R is equal to 5616 times the width, which is 1/3, times the height squared, which is 1/2 squared, all divided by the length of 15. What I would do is I would pause this real fast, try to work through this, and then see if you get the same R value, because I'm going to try to take a couple, I'm going to make this a little bit shorter than that last one since I just walked you through that last one. So this would be 1/2 squared, which is 1/4. So I'd have 1/4 times 1/3, which is 1/12. So this becomes 1/4, because 1/2 times 1/2 is 2 times 2 is 4. So 1/4 times 1/3 is 1/12. So this would be 5616 times 1/12 divided by 15. So I'd have 1/12 times 1/15, just like how we did before. So 12 times 15 is 180. So I'd have 5616 times, there's a couple different ways you could do this. 1/180. So 5616 divided by 180 is 31.2. So R is equal to 31.2 tons. And I would really encourage you to work through that calculation right here. Make sure you know how to get that. So let me erase that times 1/4. So that one was 1/2 squared, which is 1/4. So that's 1/4 times 1/3, which is 1/12. So you could do 5616 times 1/12, get that answer, then divide by 15, or you could do, since this was being divided by 15, you could do times 1/15, which I did, and then divide that number 5616 divided by 180, whatever you want to do. But at the end of the day, you get R equals 31.2 tons. So joint variation, definitely a little bit more complicated, a lot more going on, but if you understand the process and the solving, then it shouldn't give you any sort of extra challenge than the other scenarios.